So we have been asked to evaluate the integral of x power 3 multiplied by the square root of x of 1 minus x squared. So to handle this one, we're going to use u substitution, where I'll say let u be equal to the square root of 1 minus x squared. So this will be equal to 1 minus x squared. So to write this, we are going to have 1 minus x squared the power half. So here, since we have let u to be equal to this function, we need to rewrite everything in terms of u. So to start with, we need to differentiate u, where we find u, which will be equal to, differentiating this one, we drop the power, so we have 1 over 2, open, 1 minus x squared, close, then 1 over 2 minus 1, we get negative 1 over 2. Then we multiply this by the differentiation of the inside function here, we are going to get negative 2x, then dx. Simplifying this function, we have du, which will be equal to half multiplied by negative 2x, we get negative x. Then this whole part, since it has a negative power, we can take it to the denominator, where we have over the square root of 1 minus x squared dx. Making dx subject of formula, we are going to have dx, which will be equal to square root of 1 minus x squared du, then everything over negative x. But we said that u is equals to the square root of 1 minus x squared. So this can be u du, everything over negative x. So replacing this into our integral, we're going to have the integral from 0 to 1 of x cubed. So we have a u here, where there is the square root of 1 minus x squared, multiplied by the dx that we have is u du over negative x. So it will be u du over negative x. With this, we can cancel out 1x here and cancel out 1x here. Here, it will remain x squared. So simplifying this, we have limit from 0 to 1 of x squared u squared du. So this negative here, you take it outside, it will be negative everything. With this, we can't integrate because we have x squared, and we are integrating with respect to u. So we are going to rewrite x squared in terms of u, since we said u is equals to the square root of 1 minus x squared. We can simply square both sides. Then we'll get u squared, which will be equal to 1 minus x squared. Making x squared subject of formula, we will have x squared, which will be equal to 1 minus u squared. With this, we can now replace in our function, where we'll say negative integral from 0 to 1, where there's x squared, I will replace with u squared. So it will be 1 minus u squared, open, everything multiplied by u squared du. So now it's in terms of u, and it's easy to integrate. So cleaning up some space here, I'm going to say the integral from 0 to 1 of this function, I'll distribute the u. So I'll have u squared minus u power 4. Everything integrated with respect to u. So integrating this one, there's a negative here. Integrating this one, we're going to have negative here. So negative. So integrating u squared, we're going to add 1 and divide by the new power, which is 2 plus 1. We're going to do the same with this one. We add 1 and divide by the new power, 4 plus 1. In this case, the integral is going to be u 2 plus 1, we get 3 over 3. Then 4 plus 1, we get 5 over 5 plus c. Distributing this negative, we're going to have negative u power 3 over 3 plus u power 5 over 5. So since we've been given the limits from 0 to 1, we're going to plug in the limits. So since we know that it's g of b, the upper bound, minus g of a, the lower bound. We're going to get 1 and put in the formula, and get 0 and put in the formula. So to start with, we're going to have the expression written in terms of x. So I will say negative square root of 1 minus x squared. Remember we said u squared is we said u is equals to square root of 1 over x. So everything to the power 3, then over 3, then plus, where there's u, we're going to replace with the square root of 1 minus x. So we're going to have square root of 1 minus x squared to the power 5, then everything over 5. In this case, now we take our 1 and put where there is x. So using 1, we realize that when you put 1 where there is x here, it's going to be 1 minus 1, which is a 0. So everything will be a 0 here. Then when you put 1 also here, it's going to be a 0, since it's 1 minus 1, so it will be plus 0. Then this minus the lower bound, where we are going to use 0. We'll put 0 where there is x squared, it's going to be a 0. 1 minus 0, it's 0. Then square root of 1, it's 1. Then over 3. But since there's a negative here, we'll put a negative here. Plus, we'll put 0 here. We're going to have 1 minus 0. Then square root of 1, it's also 1. Then everything over 5. Simplifying this, we're going to have negative 1 over 5 over 3 plus 1 over 5. So this will now give us positive 2 over 15 as our final answer. So since when you integrate direct, it gives you area, so we can just say unit squared. Another example on new substitution, we've been asked to integrate the indefinite integral of x power 5 over the cube root of 1 minus 2x power 3. So we're going to let u be equal to 1 minus 2x power 3. Then we differentiate this, we're going to get du, which will be equal to the derivative of the constant is 0, then derivative of negative 2x power 3 is giving us negative 6x power 2 dx. So with this one, we're going to make dx subject of formula. So we'll have du, which will be equal to, we're going to have dx, which will be equal to du over negative 6x squared. With this one, we're going to plug in where there is dx, we put du over negative 6x squared. So we're going to have the integral of x power 5. Then for this part down here, we've let it to be u. So we're going to have the cube root of u multiplied by du over negative 6x squared. Taking negative 6x outside the integral, we're going to have negative 1 over 6, the integral of x. So this x squared and 2 of the x's here, we're going to remain with 3. So it will be 3x cubed over u to the power 1 over 3 du. We still have x in our expression, so we need to make it in form of u. So we're going to say, since u is equals to 1 minus 2x cubed, we're going to make this x cubed subject of formula so that we can replace in the expression. So we're going to have 2x cubed, which will be equal to 1 minus u. Dividing 2 on both sides, we have x power 3, which will be equal to 1 minus u over 2. Taking this into our expression, we're going to have negative 1 over 6 integral of 1 minus u over 2, then everything over u power 3, 1 over 3, then multiplied by du. Simplifying here the inside part, we're going to have the integral of negative 1 over 12, then 1 minus u multiplied by u to the power 1 over 3 du. So since we've simplified, we can now open the parentheses. We'll have negative 1 over 12, the integral of, so for this one it has a negative power. Since it was in the denominator, now it's up on the numerator, it will carry a negative power. So u to the power negative 1 over 3 multiplied by 1, we're going to get u to the power negative 1 over 3. Then u to the power negative 1 over 3 times negative u, we're going to have u, since is the base is the same, we're going to add the powers, so we'll have 1 minus 1 over 3 du. With this one, we'll have negative 1 over 12, then u the power negative 1 over 3 minus u. When you subtract here, you're going to get 2 over 3 du. Doing the operation inside, we are going to have 1 over 12 open, then here we add the powers, we add 1 to the power and divide by the new power, negative 1 over 3 plus 1. We do the same here, we add 1 and divide by negative 1 over, or 2 over 3 plus 1. So adding the power and dividing by the new power, we are going to have u. When you add the power here, it will be 2 over 3, then everything over 2 over 3. Then minus, we add the power here, we get u to the power 5 over 3, then everything over 5 over 3 plus c. Now that we've integrated, we can simplify our expression here. So simplifying our expression, we are going to have negative 1 over 12, negative 1 over 12 open. Where there is u, we are going to put the inside function here. So we will have 1 minus 2x power 3 over 2 over 5. This one is to the power 2 over 3. And minus, the same way, where there is u, we are going to put our expression 1 minus 2x cubed to the power 5 over 3, everything over 5 over 3 plus c. So simplifying, we are going to have 1 over 12 open. Here it will be 3, so we have a 3 down here, so it will be 3 open 1 minus 2x power 3 the power 2 over 3, then everything over 5. everything over 2 for the first part. Then minus, for this one, is going to be 1 minus 2x power 3 to the power 5 over 3. Then since here it's a denominator, we are going to flip it. We are going to have 3 over 5 plus c. Having written this, we can multiply our 1 over 12 throughout. So we're going to have 1 over 12, or in fact we can simplify here 3, and 3 here we have a 4, then this 4 multiplied by 2 here we have 8. So we're going to have negative 1 minus 2x power 3 to the power 2 over 3, then everything over 8. Then this negative and this negative here is going to be positive, so we have plus this 3 and this 12. We're going to have a 4. 4 times 2, 4 times 5. We're going to have 1 minus 2x the power 3 the power 5 over 3, then everything over 20 plus c. Meaning that our final answer here for the integral of x power 5 over the cube root of 1 minus 2x power 3 dx is simply equal to negative 1 minus 2x power 3 to the power 2 over 3, then everything over 8 plus 1 minus 2x power 3 to the power 5 over 3, everything over 20 plus c. This is our final answer. So on this one, the first thing that we're supposed to do here, we write this in integral. So I'm going to ignore the limits first. We have been given square root of 4 plus 4 cot squared 2t. So the first thing that I'm going to do is to factor out the 4 so that I can simplify my integral. What I'll have here is square root of 4 multiplied by 1 plus cot squared 2t. With this, I can relate the inside to some identity where we know that 1 plus cot squared theta is equal to cosec squared theta. So instead of having to instead of writing everything here, it's better we write its equivalent, which is cosec squared theta, meaning that our integral expression is going to be the square root of 4 is 2 squared square root of cosec squared 2t dt. We can take out the 2, meaning we're going to have 2, the integral of square root of cosec squared will be cosec 2t dt. Whenever you want to integrate, there is a standard form where we can just say, for instance, let's say we are integrating cosec ax. So integrating cosec ax, this will be equal to natural log of cosec ax minus cot ax. Then you differentiate the inside function. It's giving you us, when you differentiate this with respect to x, we get a. So here we'll say over 1 over a. So following this standard form, we can integrate our function here, where we can say it's 2 open, the derivative of 2t with respect to t is giving us 2, so it will be 1 over 2 log cosec Then the angle here, it's not ax, it's 2t. So we're going to put our angle, which is 2t minus cot 2t. So simplifying this, we get 2 and 2 will cancel out. We're going to have log cosec 2t minus cot 2t. So remembering that we've been given a definite integral with the limit as pi over 4 as our lower limit and 3 pi over 4 as our upper limit, we are going to plug in these limits. So we have log. So before we plug in everything, we want to modify these identities. We know that cosec 2t is the same as 1 over sine 2t. So we can replace it with 1 over sine 2t minus, for cot, we know that it's the inverse of tan. So we know that cot 2t is equals to cos 2t over sine 2t. So we're going to replace this one also. We'll have cos 2t everything over sine 2t. So plugging in the limits now, we're going to have log 1 over, when you put in the upper limit, we're going to have 1 over sine 2 open 3 pi over 4, then minus cos, we have a 2 3 pi over 4, then everything over sine 2 3 pi over 4. Yeah. So having written this, we are going to simplify it by saying log of, we have a 2 here and a 2 here, it's going to be over 2. Then sine of 3 pi over 2, it's negative 1. So we'll have negative 1 here, minus, we have a 2 here and a 2 here, it's giving us a 2 here down. Then cosine of 3 pi over 2, it's a 0. So we have a 0 here, meaning that for our upper limit, it's going to be log. Our upper limit is going to give us a log of 1. Negative 1 here. Apart from this, we are going to plug in the lower limit and find its value. So let me just label this as my g of b. Then plugging in the lower limit, we're going to have of 1 over sine 2. Our lower limit is pi over 4 minus cos 2 pi over 4, then everything over sine 2 pi over 4. So this is giving us 2 here and 2 here, it's a 2. Sine pi over 2 is giving us a 1. Then 1 divided by 1, we are getting log of 1. Then cos, and 2 here and 2 here, it's giving us a 2. So cos 90 or pi over 2, it's a 0. So it will be minus 0. Meaning that our lower limit, our lower bound is giving us log of 1. So now we know that for definite integral, we say the upper bound minus the lower bound. So this is going to be log of -1, absolute value of -1 minus log of 1. So log of absolute value of 1 simply log 1, and log of 1 is 1, meaning that the final answer here is going to give us a 0.